last time we discussed about the introduction of what I'm going to share with you throughout our channel, and maybe I can just remind you that about my name. That's extraction. So, okay, I'm a degree holder in GIS and remote sensing, currently enrolled in master's degree here in Kenya, and I've been doing this passionately out of career choice. I've come to realize that there is more important things that we can address through GIS and remote sensing, and that has been my desire also to share with you throughout this channel. So kindly make sure that you are subscribing, you are always liking and commenting, and tell me impact the result. So today of course we'll be dealing with machine learning. So we have to really see what is this machine learning, which are these platforms and softwares that we are going to engage in. Yeah, so first of all, okay, I'm very sorry to share this slide. This is my account on Fiverr, and I've been doing amazing things there. Getting to see a detail, so to see helping many people to really understand what I do in GIS and remote sensing. Maybe because I'm in this platform, maybe I can just show you a bit of the kicks that I've been offering. Right. So yesterday we had 7 clicks. So we just come to that. I've just generated around $492 just in a 1 kick. So I've been doing this for biomass estimation and carbon content quantification. I've also done network analysis and buffering. I've also been doing forest mapping, height detection, and I've also been doing land use, land cover, and asset mapping. That includes the flood mapping, the disaster management in terms of earthquakes, landslides, yeah, and so on. So, in case you'll wish to see more of my task, you can just look at my link in my bio that I've just indicated in my profile. So let's go directly to Google Earth Engine. So for those who are starting over today, you just open your browser if it's on a Chrome or any browser like the Phoenix, the Firefox, and so on. Just type Google Earth Engine, then you just search. So come here, click on that. So it will direct you to this page where you'll be having platform, datasets, non-commercial, commercial, and time-lapse case studies. And if you've not started, you can just click here. But for my case, because I have an account, we can just go directly to the platform itself. That's the Google Earth Engine. So it'll be directed to this platform. So on this overview, you can see that on my left end, that this is this end, it's subdivided into 3, whereby you'll be storing your scripts, you'll be having the documents. If you are stuck, you can have a look at maybe if it's an algorithm that you want to use. You have to see how you are doing the classifier, that is in terms of maybe if you are doing land use, land cover, that is the decision tree and sample methods. So then you have here the assets. So the assets will be able will make you do an addition of your area of study, so you can upload. So these are some of the features that can be uploaded either in this format, that is the GeoTIFF, TIFF files, the GeoJSON, that is the JSON file. Then we have the table of upload. You'll be having the shape files, that is you'll be making sure that whatever you are importing to Google Earth Engine has all these file extensions, that is the shape file, the SHX, DPF, PRJ and zip. And if you are doing the comma delimited, that is a CSV file, this is the file you come to this hand. And if you are also doing the image collection or the folder, you just click on that. Maybe you can try this for the shapefile, so it'll be directed to where your files are. So I don't know if okay, maybe I can just have a look if I have one of the shapefiles so that we can do a demo with that. So let's see, I think I've been doing a project. Okay, let's see the shapefile. So we'll see that this is important, so you just press that, then you control dbf prj. So spn and spx, you don't add that, so you come and extend that so you can see the file extension. So we've just add this one, so we've not add what, sorry for that, we've not add the shp, the case shx. Yeah, so if you do that, so okay, I think we've messed somewhere, so let's redo that again. Right, let's see. So we would say we are going to be adding the shp, dpf, prj, and cbj, right? Nice. So you open, so we have one. So we've not add an extension that is shp or the zip file, that's why we are getting this extension. So let's say that we do one, let's add one that is the shp is shp. Let's get back to the other shape file here. Maybe we'll be having the shp file, shp. This is look, we have the shapefile pattern that you should be able to add. Alright, okay, let's just do with this. So this one, then this is logged, tpf bsj. Yeah, so we are missing the shp because you are now seeing that you have this other file extension. So suppose you're having the shapefile path, you'll be able to get a prompt here to upload. This color will turn to be a bit of blue, and you will be able to upload that. Hope you've got that. So you'll be able to see to do the same also for the CSV files. You can just import the CSV just when you have it. So these are some of the shape files that I've done, the game set that I've been able to import, and also the projects that I have here. So if you're having a project, you can just do, you add a project, then you select, that's it. Yeah, so this is the platform, this is the view here, the content view here is the code editor. You'll be writing your scripts that, for example, map, add, layer, such and such. So that's it, right? So you can do here, you can get a link just when you've saved. You can also share the link or manage link. This is the option that allows you to save your code. Then this is used for running just when you are through with your code. Then this is used for resetting or clearing. Then after you build your code, suppose you've been tasked by your client or by your assignment person to develop an app. This is the platform that allows you to do that. Then this is the setting page. You can do the settings. Then this is the inspection. You can inspect your code, and then this is the console. So whenever you're having an error, or the outputs it will show here in the console page. This is the task. The task manager allows you to either do the exporting to your Google Earth engine for further analysis, maybe in other softwares like UTSM, ArcMap, or any other GIS software, remote sensing software. So I promise some of you after thorough inbox from my end, after getting a lot of questions from various people, various colleagues about the ecological management in terms of the new trend, that is the climate change. So we'd say that let us look at the climate change in a different perspective. Let us analyze the change in biomass. Let us see if there is a correlation between biomass, carbon sequestration. Let's see if there is a correlation between biomass and also the vegetation cover, the vegetation uh, factors, the factors of nature. Let's see if those factors really contribute to climate change. So, because I wrote a code, initially wrote a code, so we'd say that you come into scripts. So these are the codes that I've been able to develop over time. These are the codes. So I initially I was tasked to do a project in biomass and carbon sequestration for an area in Kenya, and an area in Ireland, an area in Iceland also, an area in France, and now I'm doing an area in the United Kingdom on the same. So we are just trying to educate the government officials and users that how we can tackle the issues relating to climate change in terms of looking at the vegetation health. So let me just show you the biomass for the year 2019. So someone will ask me why I did for the year 2019 and 2023 that short span. So because I'll be using various data, so let me load one so that I'll be explaining while showing. If you see that code, the code really explains that I'm using one of the datasets here was KD data or the ZI level 4B. The ZI level 4B data was launched in 2018 and became operational around April of the same year. So because these has created values for above ground biomass, sorry, then it limits me to start from the year 2019 to 2023, just because you can see here I'm starting from the month of January to December of each and every year. So because I want to maintain the consistency trend, and this is also a requirement in the geospatial data infrastructure, that you maintain a consistent time frame for you to get accurate results. So I had to do that and also make sure that every year I'm doing for the same day and same month. So if someone had to someone was dealing with a certain month, then you should be changing here. That is the month, this is the year, month and date. So you should change your month and date. Maybe if you'll be focusing on specific months, say May, January, of each and every year, this is what you should be changed. You should change here. So one of the data sets that I was using is the ZI data level 4B that I've said that it provides the graded above ground biomass. Another one was Sentinel-1. Sentinel-1, remember that this one has a higher penetration. When you are focusing with vegetation health, it can be able to penetrate in both day and night. So we were developing the interquartile ranges. You can see here, we were developing the interquartile ranges, and then we also did the projection. So And also look at the backscatter, the backscatter. Remember that in microwave remote sensing, that is the vertical polarization and the vertical horizontal polarization of the same interquartile ranges. Then we just load the post rainy season, the PV and the VH of the same. Next we did load Sentinel-2. Sentinel-2, remember, Sentinel-2 was launched around 2015, and it was very essential for us to use because it can monitor the vegetation health. We can just get more pans from that is from pand 1 to around pand 11, I guess. Yeah, so we did the masking of the same area, did reduce the cloud cover. So I'll just even here reduce the cloud cover to as low as even 5 or 4%. Let's do it 5. So the good thing with full attention and machine learning is that unlike the other GI software, you don't have to do the manual correction, harmonizing, removing the cloud cover of every image. Then you do the layer stacking, while doing the mosaicing. A very tedious job. Just here, if you have the code, you understand the code, you do it here. So I'm loading the Sentinel-2 data from 2019 of January to December. I'm also going to do the filtration, that is the cloud filtering. I'm reducing the percentage of that cloud cover to as low as any other level, even 1. Alright, you can do as any level you want. Then also be selecting the bands. This is where I told you we are from band 1 to band 12. So I'll project my composite image to an area that I'm doing. And for this, because this was an area in Kenya, I found that to be on 35, on a zone of 35 south. I'll also try to load in the DM, that is the SRTM. This is I obtained from USGS. I'll also show you later how you can be able to get the data from USGS account. So I'll paste this image from my USGS. What we'll see later, the implication of having the SRTM data on our Google Earth Engine platform. Right. So the SRTM will be able to get us the elevation, right? The elevation, and then we clip to our study area and also do the projection. Then from that, we'll extract the slope, and then we clip also. We'll try to load another important data sets here. This is the global ESA data, the land use land cover data we'll obtain from the world cover. Remember, the importance of having the ESA data is essentially to provide us with the pixel of each and every vegetation cover. Suppose we are dealing with forest cover, then forest cover we have to know that it is in which pixel cover. If it is 10, then we have to do that with 10. If it's grassland, if it's pearland, if it's say maybe maize cover, if it's what, then the land use land cover is able to classify that accordingly, because these are what has been sampled and trained. The model has also already been trained, so it'll just be extracting a certain feature class of your interest from the world cover datasets. Right, now you can see because my area was a forested area, a mountainous region, that is a part of the Mao escarpment. I'll be able to extract the forest cover because that is essential, what I'm really interested in, to look at the above ground biomass for a forest cover strand. Now, I'll extract the pixel at 10. Maybe I'll show you later how you can have a look at the forest class, the classes that are found in the world ESA data. I'll visualize the forest only, as you can see from the comments here above. Then I'll do the merging. So I'll now try to load the predictor variables. This will help me with to explain more on biomass. Let us see what the predictor variables are. So part of the predictor variables that I use is the FIFI, that is the vertical polarization, the vertical horizontal polarization obtained by the interquartile ranges. Another one was slope, another one was elevation, another one was the forest curve, and then we have the bands from band 1 to band 12. Then we'll be able to see if the area was a mountainous region. Are we expecting the predictor variable importance to be really the band 1, the band 2, band 4, band 5? So each and every band is usually associated with a certain use. For example, band 5, 4, that is used to monitor the vegetation health. So if you see band 5 and 4, band 7, band 11, we should be expecting that to be at least more than band 1, because that is used to monitor the vegetation health in terms of Sentinel-2 composite image. Then we'll also be expecting part of the elevation, because we all know that because our area is covered by a thick vegetation and it's a mountainous region, sorry, so it has remained undisturbed from, say, deforestation rates, human conflict with the forest factors. So it has remained undisturbed for a long time, and we'll be expecting that elevation is also an important predictor variable in our project here. Let's continue. We'll clip that and then we match. Then these are also the bands to include in our classification. This is the KDI data that we used. Then we also sample the training data sets from the KDI data, right? After sampling, we have to split that to training and testing as a matter of course. We'll be using 70% for training, 30% for validation. Then we collect the training, of course. We use the model algorithm that we'll be using is the RF, that is the random forest classifier for regression analysis. Then we do the classification and clip to a boundary. Then this is the code that will allow us to have a look at the palettes in terms of colors to be used. Alright, we'll visualize this to our Google Earth engine. Then we'll create the charts that will be able to allow us explain our project in terms of visualization. Sorry, we'll create a legend, also thumbnail for image that will be showing the amount of biomass in that given year from as low as the lowest value is the highest value. That's the code. Then we also in terms of validation, we'll be able to compute our root mean square, the variance also. We'll get that, and then we print also in form of charts, right? That's great. Then after getting that, this is the code that allows us to export. I told you that the taskbar on my right hand is used to export our images to Google Drive. So because this was 20, I think this was 2019. So we'll just write here 2019. Mean value of the above ground biomass for 2019. You can just write biomass 2019. That's it. So long as you maintain the code in the right format, you'll be shown if there is an error. Suppose I remove this, you see an error has occurred, so you'll be notified about that. So we can just correct our error. So after ascertaining that the code is correct, we'll just click on run. Run is used to execute our code. So let's execute that and give some time. We executed that, then we give some time to process the results. So let us see. So remember that our area was in Kenya, an area that is fully covered by forest. It's actually Mau Forest, but there is a mountain there by the name Mount Londiani. So I want us to amazing. So you see, these are our products. So I told you that the console is used to look at the results, what you attain in terms of result. So for example, we had the projections done and transformation. We loaded the post rainy seasons. We also did the matching. We clipped and matched the predictor variables. We did the feature training, feature collection, validation, variable importance. So this is the part that I told you. But before we come here, I want us to look at our product. So I'll just move our code editor up so that we can and look at the trend. So for 2019, the mean above ground biomass was for the lowest area was 22.1, let's say 77 milligrams per hectare, and going to as high as 155.73 milligrams per hectare. So we can really from our map zoom in and try to really look at the green part. The most green part was having high amount of biomass. So let me check this, then we can just remain with one. Let's remain with mean biomass, or because I have not changed the color, let's remain with trees. So you can see that the tree coverage is at this moment, this part, the patches of green. So where we have patches of white is almost bare land. Alright, so recreation, I'll just do that. So the green part will be used showing us the mean biomass. So we'll just export this and look. Yeah, you see that? That's amazing, right? So at this the place that we're having a mountain. Let me change this to so that we can prove if what we are really getting is the true. So this is the mountain. As you can see, this region is where we have the most green part. This is the forest cover, right? Let me see the tree cover. You can see that. You can see that, and you can really appreciate. So from the global land use land cover, the ESA data, we are able to extract the tree coverage alone in a forest stand. Yeah. So through that, we can now use to measure biomass. We can use to measure biomass, right? Now I want us to look at the console and see the products that we're having from the predictor variable. So I'll just click this. You can see for yourself. Let us see which was the most important predictor variable importance. The first one was the elevation. Remember I told you that the area was afforested and also with a mountain. It was really mostly covered by the mountain, and you can see that we are having the forest cover here. So you can download, or you can do the CSV. You can download in form of image or the CSV just like that, and it will download. So let's come and see the predictor variables. So these are the predictor variables. You can see we have, if you click here, you'll be able to see these. It means that there was a direct relation between the predictor and observed values. We also have the training, the root mean square, predicted in terms of validation now. This is the variance. That's it. That's it. In our next video, we'll be able to see how we can estimate biomass using a geometric equation, because we'll try to see how we can use maybe other products like LiDAR data and the such and such. So this is the part that you can now run. You submit the Google Earth Engine for various analysis. So thank you for your time. In case you'll be having a question, I've just left my email there, and we can get in there and discuss. I've also left my